Let's turn our attention now to looking at probabilities of two events. Now, there are a couple of different ways we can look at them. We can look at two events happening one or the other, or we could look at both of them happening at the same time, meaning one and the other. We'll start off with the first one, talking about or probabilities, having one event or the other. Let's go back to this example here. We have a bag of 20 marbles. Two are purple, three are red, four are green, five are yellow, and six are blue. So if I draw a marble at random, what are the chances of getting either a red or a yellow marble? Now recall how we did this before. We said, what's the probability of getting just a yellow marble? We said, well, there are five marbles in there that are yellow. I could draw any one of those five and it would be a success. Well, in this case, we're saying it could be red or yellow, so we're adding them together. So we have the three reds and the five yellows. Any of those eight marbles are possible. So the probability of drawing either a red or a yellow would be the total number of successful marbles. 3 plus 5 is 8 out of the total of 20 marbles. And 8 over 20 would be 0.4, which, as we discussed before, would be 40%. Great. That's pretty simple. So that brings us to the definition of an or probability. If we have probability of one event or another event, then we just add the probability of the first event to the probability of the second event. In this case, red or yellow. What's the probability of drawing a red plus the probability of drawing a yellow? And you can see that this math is exactly what we just did. We said that the total number of marbles I could pull out are the three reds or the five yellows. 3 plus 5 is 8. So that's how you do an or probability. Well, for the most part. We'll talk about the most part in a bit. We'll come back to that. So here are a couple of examples. Let me read through them and then pause the video, see if you can figure it out on your own. When you roll a die, what is the probability of rolling either a 1 or a 2? And when you roll a die, what's the probability of rolling an even? Now, these may look familiar. We talked about them back in lesson 9 when we were talking about probability. But I want to revisit them because the way we solve them now, the way we solved it back then in lesson 9 is essentially how we do or probabilities. So take a second, apply what we learned about or probabilities, and see if you can answer these two questions. Go ahead and pause the video. All right, so what's the probability of rolling either a 1 or a 2? Well, there are two ways to get a success. You could have a 1 or you could have a 2. So there are two ways to get a success. So following the definition of or probability, what's the probability of 1 plus the probability of 2? Plus means or means plus, right? Either way. If you have an or probability, you're going to add the probabilities together. So the probability of rolling a 1 is 1/6. Probability of rolling a 2 is 1/6. Add those two together, you get 2/6. If you recall, when we first did this problem, we said there are two ways we can get successes: rolling a 1 or rolling a 2. Two successes. And that's what we have right here. Let me grab my laser pointer. There we go. There are our two successes out of our 6 total number of outcomes. Okay, so the or probability just helps that happen naturally. All right, what's the probability of rolling an even? How can we roll an even? Well, you can roll a 2 or a 4 or a 6. So probability of rolling an even is just an or probability, 2 or 4 or 6. So what do? What's the probability of 2 plus the probability of 4 plus the probability of 6? Which each one of those is 1/6, adds up to 3/6, which is 1/2 or 50%. And that's exactly what we got back in lesson 9. Now, sometimes this goes wrong. Here's another example. Let's take a deck of cards. A deck of cards has 52 cards, 13 hearts, 13 diamonds, 13 spades, 13 clubs. These are the 4 suits in a deck of cards. And each suit has 4, that is a typo there. Each suit should have 1 card of each value: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So each suit has 1 of each value. So what's the probability of drawing either a queen or a heart? Okay, there are 4 queens, there are 13 hearts. So if we follow our equation normally, then the probability of drawing a queen is 4 out of 52. Probability of drawing a heart is 13 out of 52. Gives us a total of 17 out of 52. Simple enough, right? Except that answer's wrong. Why? Well, here's the problem. Okay, so we have 4 queens, 13 hearts, and going through the math that we had before. Here's the problem. If we highlight all the cards that are hearts and all the cards that are queens, notice that there's 1 card, the Queen of Hearts, that got counted twice. It was counted as a queen, so it was counted in this group, and it was counted a second time as a heart. So what do? Well, we counted it twice. How about we uncount it once, meaning we subtract it out? That is the key. So if we take the probability of a queen or heart being probability of a queen plus probability of heart, we've double counted the Queen of Hearts, so we subtract the Queen of Hearts, meaning we subtract the probability of a card being both a queen and a heart. Since we counted it twice, we just subtracted out once, which means probability of a queen is 4 out of 52. Probability of a heart is 13 out of 52. Those two added together were 17 out of 52, right? Remember that? But now we subtract 1 because there's 1 card that is both a queen and a heart. And that gives us a total probability of 16 out of 52. Now it is correct. So that teaches us exactly how to do an OR probability. Whenever we have 2 events, we have to account for the possibility of overlap. And to do that, we add probability of A plus the probability of B minus that little overlap region since it got counted twice. And that's how you calculate OR probabilities. Next time, we'll talk about mutually exclusive events, which we've talked about here. We just haven't pointed it out yet. That will be in our next video.